Okay, so you've got your notes labeled quadratic inequalities. That's what we're dealing with today. What's going to be the major difference that you'll see today is the inequality sign. So instead of having a quadratic that says, just made up, for example, 5x squared plus 13x plus 12 equals 9, now instead of the equals, it's going to have a greater than or a less than sign. So what we're going to do with these, y'all listen, what we're going to do with these is we're going to look at the graphs of them, and then we've got to figure out what part of the graph is included based on the greater than or less than sign. So there's a lot of shading that's involved in this. So my kindergarten scribbling skills come back to visit us pretty good. So let's look here. I've got y is less than negative x squared minus 2x minus 1. Alright, so we're just going to graph this. So to start with, not worried about the less than sign, just looking at my function, I got to decide my method for graphing, so I got to know what form it's in. Is it in vertex form? Is it in standard form? Is it in intercept form? What are we dealing with? It is in standard. Very good. When this is going to take us back and review some stuff. When we're in standard form, the method that we use to start graphing is our axis of symmetry, negative b over 2a. Okay, I told you quadratics are all year long. That stuff is not going to go away. So negative b, so I'm going to have my negative 2, and then my b is negative 2, and then my a is negative 1. Now I know I've seen a lot of y'all writing these down, and y'all write that different than me, and I'm alright with that. Just be super duper careful with your signs. What I know is going to happen here, my axis of symmetry is going to be x equals some negative number. I can tell that here because the negative divided by negative is a positive, divided by another negative is a negative. Okay? So my axis of symmetry is going to be x equals some negative number. What negative number is it? 1. 2 divided by 2 is 1, so I've got x equals negative 1 to start with. So I'm going to have negative 1 comma something. I'm going to go ahead and go over and dot my axis of symmetry. Remember that stuff we did when we were graphing? So I'm going to go left 1. There's my axis of symmetry. Now I got to figure out how high or how low my vertex is. So what do I do with that negative 1 to figure out my max or my min? Plug it in. Very good. So I've got negative. I'm just plugging it up here. Negative 1 squared minus 2 times negative 1 minus 1. Let's see what we did there. Negative 1 squared is 1, but then you got to put that negative back in front of it. Negative 2 times negative 1 is a positive 2. So negative 1 plus 2 is 1, and 1 minus 1 is 0. So my vertex is at negative 1, 0, so it would be right there. Okay? Alright, but that does not make a parabola. I just gave y'all a hint on which way it was going to open. I scooted it and dropped that line. Did y'all know it was going to open down? Look at your original equation. You got an a that's negative, so that tells you it's going to open down. Alright, that doesn't make a parabola. What do I do to get another point so I can make a parabola? I can plug any other number I want to in as long as it's not on this line. So I could plug 0 in, couldn't I? That'd be the easy thing to do. So go up here and look at your original equation. If you put a 0 there, that would go away.
Negative 1.
Put a 0 there, that would go away. So Garrett's right. We would have a point on 0, negative 1. So that'd be right down there. I need to scoot it up so y'all can see it better. Now, how do I get that on the other side of the axis of symmetry?
You just count it over.
1, 1. Okay, now do not connect your parabola yet, because here comes the new stuff. The original sign in this, if I scroll it back up so you can see the original problem, said less than. It doesn't say less than or equal to, it just says less than. So my parabola can't be a bold line, a bold curve. Y'all remember this from doing lines before? If it's just less than or greater than, it's dashed. Remember in Algebra 1 when you did that on a line? Same thing on a parabola. If If it's just less than or greater than, you're going to connect that parabola with a dashed curve. So, I got a marker pick, yep. Alright, now here comes the scribbling part. My function said y is everything less than that quadratic. So at some point I'm going to have to shade a section of this graph that's got going on here. And here's your options. My answer could be everything that is outside of the parabola. That could satisfy the function, could make the function true. Or my answer could be everything that's inside of the parabola. That could make the function true. Okay, so all you've got to do now is pick some random test point and plug it into your original function and see if it's true or false. Excuse me. Here's the guidance I give you. I pick a point that is inside the parabola. So somewhere, something's in my throat. Somewhere inside here, I'll pick a random point, plug it into that equation. If it makes a true sentence, then that's the part I'll shade. If it makes a false sentence, then I'll shade everywhere else. Okay, so let's just find a good point somewhere in this parabola. How about right there? That's in the parabola, right? I like that one because it's got a 0 in it, so it'll be easy. That is over 0 and down 2. So I'm using 0, -2 as a test point. Alright? Go back and look at your original function. Now what if somebody else picked another point? Right. As long as you do the math correct, Maddie is exactly right. You can use any point you want. So I'm going to go back up here. I'm going to plug a 0 in for the x's and a -2 in for the y. I'm going to see if that statement becomes true or false. So -2 is less than 0 squared is 0. 2 times 0 is 0. So all that's left is -1. So there's my sentence I'm evaluating for true or false. Is that true or false?
That's true.
It is true. -2 is less than 1, right? Is less than -1. Excuse me. -2 is smaller than -1. So that is true. So that means that that point is part of my solution. And the point is inside the parabola. So my answer is everything that is inside that parabola. Okay? Beautiful. Every year when we do this lesson, I always want to call the art teacher over to show her what a good artist we are. I just said every year. You remember something?
Yeah, I remember exactly how to do this. I know when we started.
That's what I'm talking about. Alright. Everybody okay on that? What if that had made a false sentence up there?
Then
you would have shaded everything out.
Right, I would have colored like crazy on the outside of that parabola. Okay? Oh. Okay, let's do something else. Got what we need there? Hold on. Get with the program. Stand. Piece of graph paper. Let's go. -x squared plus 3. Bless you. Check this meanness out. I'm giving it 2. Greater than or equal to x squared plus 2x minus 3. Okay, so this time we've got 2 functions. So here's going to be our order of how we're going to roll with this. We're going to do everything we just did on the last problem to both of those. So we're going to graph that first parabola, figure out if our curve needs to be dashed or solid. Then we're going to pick a test point inside it and figure out if we shade inside or outside. Then we're going to do the same for the second parabola. Graph it, figure out if our curve needs to be dashed or solid, pick a test point in it, and figure out where to shade. Then our ultimate answer here is going to be where the 2 shadings for the 2 parabolas overlap. So we should end up with a section where the first parabola shade stuff overlaps with the second parabola shade stuff, and that will be your answer. That will be the solution that we're looking for. So both of these parabolas are set up. I should have color coded. We'll do the first one in red. Both of these are set up nice in standard form for you. So we're going to find the vertex. What's our B in this first one? 0. Very good. So 0 divided by anything is 0, right? So we know the axis of symmetry is going to be at 0. What's your B? Say, what did you say?
That's your B and the X squared.
Nope, remember it's AX squared plus BX plus C. Right. So if you do 0 divided by 2A, you get 0. Okay? Now if I plug that 0 back in, where's my vertex going to be? Positive 3, right? So I'm going to go over 0 and up 1, 2, 3. Okay? Now when I go to pick another point, I can't use 0 because I just did. So I got to pick another point that's close. What'd you say, Grant?
2, 1. Oh wait, 1, 2, 1, 2.
Well, I can plug one of those in.
1.
Okay? I think Grant is telling me the final answer. He doesn't know that that's not what I wanted. But 1 squared is 1. And then I got to make it that negative, so that's negative 1, right? And then negative 1 plus 3, that's where Grant was getting the 1, 2 from. So I go right 1 and up 2. Does that make sense that this looks like it's going to open down? Look at your equation. Is it supposed to open down?
Yes,
Yes, very good. Match that thing on the other side of the axis of symmetry. Okay, so when I connect my parabola, is it going to be on this one? Is it going to be solid or dashed?
Wait, so we never used the second problem.
Not yet. We're going to.
It's going to be dashed.
It's going to be dashed, good, because it's just less than up there.
Wait, how do you know if it's solid?
If it's, whoa, there's me and my sister on a hiking trip. There it is. If it's got just less than or greater than, it's dashed. So this second one, when we get to in here in a second, look at the second one, Tori. It's got that line underneath it, so it'll be solid. Alright, I gotta finish connecting up my parabola. Okay, now I need to figure out where to shade on this dude. Ask me. Alright, so to figure out where to shade, what I gave you guidance to do was to pick a point inside the parabola and plug that in to test it. So my all-time favorite point just so happens to be inside this parabola. So I'm going to test 0, 0. So I'm going to say 0 is less than 0 squared is 0 plus 3. So I've got 0 is less than 3.
True.
That's true, so that point gets colored. So I color inside that parabola. Okay? Now, I'm just now caught up to what Garrett said, because so far we haven't done anything with the second parabola yet. We're done with the first, now we're moving to the second one. So I'm going to do all my second one now in blue. Alright, so I got to start the same way. I got to find the axis of symmetry in the vertex. So here I've got x equals negative. My b is 2.
Negative 2 over 3 times 1.
Very good. So that just gets me negative 1. Very good.
So your axis is negative 1.
Yes.
Sorry, can you just let me go park to the office after class?
Yes.
Thank you.
So there's my axis of symmetry. Now I got to plug that back in to get my min or my max. So negative 1 squared is 1. 2 times negative 1 is negative 2.
Minus.
So it'll be negative 4.
1 minus 2 is negative 1. Minus 3 is negative 4. Yes, sirree. So I got to go down 4.
I don't
It's hard to
see
see.
that
1,
line.
2, 3, 4. Jot that on down. Now keep in mind up there on my red scribble, this red scribble would still be coming down, wouldn't it?
Mm-hmm.
Right? Everybody with me on that? Because the parabola keeps going down, so that red scribble will keep coming down. Do I need to scribble some more for you, or can you envision that?
We're good.
I just like to scribble. Y'all ever want to know more about me, I'll tell you about my scribbling in kindergarten. Alright. Can I, this is so hard to see, isn't it? Can I plug, oh, it's easier to see on the computer, I'll just stay back here and make y'all some. Can I plug 0, 0, can I, not 0, 0, can I plug 0 in to get another point?
No.
Yeah, it's not on my axis of symmetry, so I can plug 0 in, so I'm going to do 0, comma, let's go back and look at our equation 100 and see what that would give me. 0, 0, negative 3. So I can go over 0 and down 3.
So, can
1,
open up.
2, 3. Yep, Grant's right. It's going to open up. Count that thing to the other side.
It's gonna be solid.
1, 1. Now, you can see down there on the bottom, I got my 3 little blue parabola dots, and I was going to ask you if I draw it dashed or solid, and Grant said solid, and he's correctamundo, because this equation, or it's not an equation, excuse me, this function started off with a bar underneath it. And that's what Tori was talking about earlier. If it's got that bar underneath it, it's solid. So I'm going to come down here. Come on, drag. Drag. I'm going to draw that thing solid. Notice I extended it up more than I normally would because remember I told you we're ultimately looking for where the shadings overlap. Now my favorite point when I can use it is 0, 0. Does 0, 0 lie inside this blue parabola? Yes, so I'm going to test 0, 0 again. So I got to go back up and look at my function. If I plug a 0 greater than or equal to 0, 0, negative 3. So this says 0 is greater than or equal to negative 3. Is 0 bigger or equal to negative 3? Yeah, 0 is bigger than a negative, isn't it? So yeah, that's true. So I'm going to shade inside the blue parabola, just inside the blue. So I kind of go around the edges to make sure because it's hard to differentiate. Alright, now my final answer on this shebang
Overlap.
is going to be where I have blue and red both. And that's fixing to magically make a yellow highlighter. Blue and red both.
You have 0 and 0 both.
How are you going to figure out anything like that?
That's my answer.
Yeah. That's a mess.
That's so, like, I'm OCD.
Alright, so let me talk a little bit about what they're trying to ask a little bit here. My answer is everywhere the blue and the red overlapped. So this parabola coming down to this parabola going up. So it's ultimately almost like an oval shape. Because from this parabola coming down, it's overlapping. And then this parabola coming up, it's overlapping. So yeah, kind of like a diamond in that, where those two parabolas overlap. So what that means is, if I picked any point out of that mumbo jumbo, it would make both of those functions up there true. Like if I plugged in negative 2, 0, if I plugged in negative 2, 0, it would make this sentence true and it would make this sentence true. Okay, it would satisfy both of those functions. Possibly. That just kind of looks like finger paint through up.
Yeah.
It's just a mess.
We have a short period.
I'm aware, Garrett. That's why I get paid the big bucks. Thank you for reminding me, though, because I am getting on up there. Tori. Sure.
Thank you.
All right.
First date, flip it. First date.
I don't know, Maddie, I don't know. Today it is at 2:55. Well, that's one. Now you know.
Rally today, even though it's not home game.
We are.
We are?
Well, Garrett just announced to me that we were on pep rally schedule.
I'm sorry. I was not.
Garrett, you're gonna have to start being
I'm
Chloe's
in my own
personal
little world
announcer.
today.
The
Listen,
kid Chloe.
you either get like just zoned out Chloe or crackhead Chloe. Yesterday you
Whoa.
saw crackhead Chloe. Today I'm chilling. Take your turn. Like it was nothing possible. I was not actually a crackhead. I'm just ADHD. There's no difference. Some days I was. Yesterday was just bad. I told my mom to take like I self-diagnosed myself. And she was like, you haven't like actually.
Okay,
No, but like,
I'm gonna give you listening. Shh. All I've got is y is less than or equal to x squared plus 5x. So I'm just giving you one. Marshall, I'm just giving you one. I want you to try right there at your table with your table buddies.
wait, no.
Just one. So there's no overlapping. Shh. There's no overlapping. You just got one.
Okay, it's gonna be solid.
It's in standard form. You got to be able to graph that. That's not new. Graphing, it's not new. The only new thing is where you're going to scribble. So you need to be able to graph it for sure.
No, it's
How'd you get Oh, you have to do this. Yeah, okay. That's all I got.
I got blue and white one.
What'd you get?
What do we do now?
Maybe make it a
Yeah, it'd be like 2.5.
You get a B1.
I know how to make.
If we have close functions.
Non-equal.
What's his name?
Hunter, y'all got it?
Hold up. Don't slide it.
Take the mask off. You weren't here when you were at like, yes,
I don't know how to shade it.
kind of weird, honestly.
Wait, how'd you get that? How many people actually? How many people actually asked me? Me?
I don't remember doing that.
Okay, well, and probably someone else. That's what I call best.
Hey, y'all need to be trying. Come on.
I
What'd you get for your X? That's the same thing. I just wrote it as a fraction. It's the same thing.
Look way down.
What's the
Look way down.
the one with the X?
Make sure it's that one.
Not the X squared.
Hey,
Casey, don't you plug negative 2 halves in?
it's right here. Right along the crease.
Don't you plug
got it all
negative 2 halves in?
Do you have to?
There you go.
Yeah.
You can write it as 2.5 or negative 2.5 or negative 5 halves. You can write it in any of those forms.
I think I'll just trust that I know how to do it. After I lost your crying.
Oh, I got added. Okay.
I'm so confused.
There's nothing new until you get to shading. You gotta figure out how to graph it. What'd you get for your axis of symmetry?
2.5.
Positive or should have been a negative. Okay. Then you just plug that back in. You can type it all in your calculator.
I put it in as a fraction.
That's okay. You can put it in as a fraction as long as you put it in. I didn't do more.
Only if one.
Did you get this?
Oh,
I'm still typing in it.
oh, so your axis and symmetry is one of your points. Okay.
7.5. So these 2.5 and 7.5.
Okay. That range, I've got something different, so.
I got
Negative.
18.
Yeah, I
Because
guess
we
you probably kept this
did
as a negative.
Negative
Like,
25.
No, I'm saying positive.
I put mine as a fraction. So it's probably the same thing. Yours is just
That's gonna be a 4.
Oh, I see what you're doing.
No, yours is.
there's no way this is right.
That's 5 and 1/4.
No, I put it around the negative 2.
5 and 1/4.
Oh yeah.
I'm so stupid.
Negative. It's
18.75.
This deck is
I don't know. No.
I'm looking at hers right now. I don't see what she typed wrong.
8.
Yeah.
oh, no, okay, so did you do 2.5 squared?
She typed that
Oh,
in
it's
there.
it's in there. It's 2.5 squared.
Oh, I see where yours is wrong. Should be a negative right there.
Oh, okay, I did it right. Huh?
Alright, so it's not 18.
So it's about 18.75.
I don't think
I
I
had it wrong on all the same.
So did you trust
I got
the smart one?
negative.
You made a simple calculator mistake.
That 18 is not. That's what they
Over.
type that squared. Remember, if it's a negative, you gotta put it in parentheses.
Okay, where did it go to negative?
I gotta do something.
It's so unfair.
It's over down, right?
Do I look like I know?
Okay, yeah, that makes a whole lot more sense.
I don't. I'll choose I don't.
No wonder we thought it was so good.
Hey, Bradley, it's opening down, right?
Yes.
Yeah.
Alright. Negative on your X. On your axis of symmetry, I saw different people writing it different ways. Negative 2.5, negative 2.5, negative 5 halves. Those are all the same thing. So you could write that any way you wanted. So from my origin, I moved over 1, 2.5. So there's my axis of symmetry. Now when I go to plug that back in, the mistake I saw most was what we've talked a lot about. When you square a negative in your calculator, you got to put it in parentheses. And then you have 5 times negative 2.5. So I believe when you did that, you got negative 6.25. So negative 6 1/4. So I'm going to go down. Whoops, come on, scroll with me. I think that's going to take me off. Take me off the bottom. 1, 2, 3, 4, 5. So I'm just going to say 6 1/4. It looks to be about right there. Okay. Now I got to pick another point to plug in. Make out one. Any 3 it will be way far away.
Sorry.
I need it to be in the ballpark. Okay, negative 3
That's
would
what I
work.
meant.
I got you. Going negative 3 would work. So that would be 9 plus negative 15, which I think is that negative 6.
Attention students, National Honor Society dues, $10, are due by October the 15th. Thank you.
So I'm going to go left 3 and down 6. So here's 3. 6 will be just a little bit above it. Is this parabola going to be solid or dashed?
Solid.
Solid. It had an equal line underneath it. All right. Now, and I'm extending this like crazy because you know I got to scribble. I'm not positive on mine that 0, 0 is included. I extended mine out there because I really want it to be, because I like to plug in 0, 0 as my test point, but I'm not completely positive. I could have drawn that badly, you know what I'm saying? Yeah. So I'm going to pick one more central that I know for sure is included. So I'm going to go 1, 2, 1. I'm going to test -2, -1 and see if that's true or false. Okay, but like Maddie said earlier, you can pick anything you're sure is in there. So I'm going to come up here and plug in -2 in the x and -1 in the y. -1 is less than or equal to -2 squared is 4. 5 times -2 is -10. So I have -1 is less than or equal to -6. Good. I wanted this. We finally got a different answer. Is -1 less than or equal to -6? No, that's false. So that means I cannot shade inside. My scrollers. I shade outside like Chloe said. So it's going to look like everything that's not in the parabola. Okay. Alright, so here is the important connections and takeaways for you. There was absolutely zero new math involved in this lesson today. Graphing parabolas, we spent a whole unit on. We already know how to graph. Okay? You did not have to do any kind of new math to figure out where to scribble. You just plug numbers in, plug and chug. So it's just picking a number to plug in to figure out where to scribble. That was nothing new. Okay? You just have to be willing to try something and do it instead of sitting there like an monologue saying it's ugly. Because it is ugly. I know. But there's nothing new involved in it. Okay? Alright. Here's where we are, where we're going, what's coming up next. Monday, we're going to get a study guide. We're going to talk study guide Mondays and Tuesdays. Wednesday, you're going to take a test. And then after that, we'll start on another project. Okay? Everybody good?
Yep.
I'm on the 88.